Kia ora team, my name's Ben and this Skux Deluxe is
Houston.
And today we're going to go through
Physiological reasons for fatigue during a 400 meter race.
Right. Alright Mr. Houston, what's one of the reasons for this fatigue?
Creatine phosphate depletion is a major cause of muscular fatigue.
Good, because if you're doing a 400 meter race, what type of intensity are we doing?
Fast.
Good, fast, high intensity. So how do we remake our ATP?
Creatine phosphate.
Good. So ATP releases energy when we split it, break it. Okay, and then it becomes
ATP.
Good. But to use it as energy, we're going to have to turn it back to
ATP with creatine.
Good. So creatine phosphate is floating around in the cell. If we break that, then we can take the phosphate, add it back to our ATP, so now we've got a TP again, which we can use for energy. So when we run out of creatine phosphate, we're going to get muscular fatigue. Alright, Mr. Houston, what's the next physiological reason for fatigue?
Fail-safe mechanisms in the central nervous system and muscles cause contraction speed too slow.
So what does that mean? If we keep exercising at a high intensity, eventually we're going to exercise ourselves to
death.
So, in our brain and in our muscles,
it slows us down so we don't die.
Brilliant. Okay, Mr. Houston, what's up next?
Increase in inorganic phosphate and ADP.
And what does that cause?
This may slow the release of calcium from the sarcoplasmic reticulum so that muscle force declines.
Alright, so what's the sarcoplasmic reticulum?
It's the bucket.
Okay, so it's like a bucket in the muscle cell, and what does it hold?
Calcium.
Who cares?
The muscles care.
They care because, what's this?
Myosin.
And this is?
The actin binding site.
Good. So, they always want to
bind.
Good. But what keeps them apart?
The trypomyosin.
Good, which is held there by
the troponin.
Good. When calcium is released from the sarcoplasmic reticulum, it binds to the
troponin,
which pulls the
trypomyosin
out of the way of the
actin and myosin.
Good. So therefore, we can get a contraction.
Yep.
So if a build-up in inorganic phosphate and ADP cause slowing of the release of calcium, that means we're not going to be able to contract as well because we need calcium to expose the binding sites.
That's it.
Oh, thank you. What's up next?
Increase of ADP may reduce muscle contraction velocity when creatine phosphate is nearing depletion.
Why would contraction velocity decrease when creatine phosphate is nearing depletion?
Because ADP can't change into ATP fast enough.
This guy. What else do we have? This guy. Okay, what's the last point?
Increase in hydrogen ions inside the muscle, which lowers pH, might also be a factor in fatigue.
So when the body gets more acidic, it may make us fatigue. Do we know this for sure?
No.
No. So we got conflicting evidence, so may or may not. So we'll check back in 5 or 10 years and see what the research says.
Sounds good.
Alright. Boom!